Next topic is evaluation of real definite integrals. Real definite integrals. Here, see, there are two types of integrals in your syllabus. First one is case 1. Evaluation of the integral of the type evaluation of integral of the type integral 0 to 2 pi function of cosine theta and sine theta d theta. Okay, this is the first model. And how to solve method, how to evaluate this integral. Okay, you can integrate using your intermediate techniques if the integration is very simple. If the integration is very complicated, then how to evaluate? What is this integrand? Integrand is a function of cosine and sine theta, and the limits must be 0 to 2 pi. Remember this point. Limits must be 0 to 2 pi. Okay, this is the point. Then how to evaluate? So what is integral first? To evaluate this integral, I will not allow now onwards. Okay, enough. To evaluate this integral, let e power I theta equal to z. Let e power I theta equal to z. Why I am taking this substitution, I will tell you. Okay, what is the limit? What are the limits? 0 to 2 pi limits, and I have to evaluate this integral using what? Using residue theorem. This is important, not general form, not general evaluation of integral. I have to evaluate this integral using residue theorem. So first assumption is let e power I theta equal to z. Then actually, you know this logic. E power I theta means what? Cosine theta plus I sine theta. E power minus I theta means what? Cosine theta minus I sine theta. Then, therefore, what is cosine theta now? By adding these two, I am getting e power I theta plus e power minus I theta by 2, correct? But what is e power I theta? I have taken assumption z. And e power I minus I theta becomes what? 1 by z by 2. This is the assumption. Similarly, what is sine theta? Sine theta becomes what? E power I theta minus e power minus I theta by 2i will be there. So this is z minus 1 by z whole by 2i. Z minus 1 by z whole by 2i. These are the substitutions. Therefore, cosine theta is, you have to remember this. If I substitute e power I theta equal to z, cosine theta and sine theta in terms of z values, z minus 1 by z by 2i. Z minus 1 by z by 2i. Then since what is z equal to e power I theta, then what is mod z is nothing but mod e power I theta. What is mod e power I theta? That is 1. Mod cosine theta plus I sine theta. So the mod z is value what? 1. Therefore, if we substitute, this is final. Therefore, if we substitute z equal to e power I theta or e power I theta equal to z, then the above integral becomes integral. What is the integral actually? Given integral 0 to 2 pi function of cosine theta sine theta d theta is equal to integral. What is this becomes in place of cosine and this one z plus 1 by z by 2 is one thing, z minus 1 by z by 2i, this is another one. And what is d theta becomes, see, this is from this I can write differentiating on both sides, dz is nothing but I into e power I theta d theta, isn't it? Right? So what is e power I theta, sorry, d theta value? This is, what is this? I'm giving here. What is this? dz equal to I into, what is this, is z d theta. So d theta is nothing but what? 1 by iz dz. 1 by iz dz. So 1 by iz dz. So this is what? This is 1 by iz dz. This is integral over c, where what is c value? C is the unit circle. Just now we got mod z equal to 1. So see, the real integral 0 to 2 pi function of cosine and cos is now transformed to what? Is now transformed to what? This is nothing but integral over, say, some function of z dz. Some function of z dz, where c is unit circle. C is unit circle. Evaluate this integral. Now this integral can be evaluated using residue theorem. You evaluate this integral using residue theorem. Using residue theorem. This is the method to evaluate the real integral. What I am taking, once again, cosine and sine theta are transformed to z terms by taking z equal to e power I theta, z equal to e power I theta. Okay, when z equal to e power I theta, mod z equal to 1. So in the given integral, cosine and sines were replaced by z terms, and d theta is also replaced by z. So entire integrand is a function of z, and over c. C is what? Mod z equal to 1. 0 to 2 pi becomes the curve mod z, the circle mod z equal to 1. This integral can be evaluated using residue theorem. Now, one problem. Show that integral 0 to 2 pi, integral 0 to 2 pi cosine 2 theta by 1 minus 2a. Okay, let me tell you first, instead of cosine I will take 1, because cosine problem is solved in textbook. 2a cosine theta plus a square d theta equal to, I think, just wait, this is exercise problem. Yeah, 1 by 2a cos theta plus a square equal to pi by 1 minus a square. Pi by 1 minus a square. 0 to 2 pi 2r cos theta plus r square equal to pi by 1 minus r square, right? Where a lies between 0 and 1. A lies between 0 and 1. Okay, I have to solve this problem now. Solution. First, what is the assumption? Put e power I theta equal to z. Put e power I theta equal to z. Then what is this is I into e power I theta d theta equal to dz. Done. So this is I into z into d theta equal to dz. So I'm calculating first d theta. So this is d theta equal to 1 by iz dz. One part is over. Then when I put z equal to e power I theta, then what is cosine theta? What is the required in the integral? Only cosine is there. So only cosine is required. Cosine theta is nothing but what? Z plus 1 by z by 2. Z plus 1 by z by 2. Then what is our integral? Integral. Okay, one more point. Then mod e power I theta equal to mod z. That implies 1 equal to mod z. That is nothing but mod z equal to 1 is the unit circle. Unit circle. Then integral 0 to 2 pi 1 by 1 minus 2a cosine theta plus a square d theta is equal to, now integral over c, a transform to integral over c, 1 by, what is this, 1 minus 2a. Cosine theta means what? Z plus 1 by z by 2. Z plus 1 by z by 2. Z plus 1 by z by 2 plus a square. And what is d theta? Dz by iz. Dz by iz. So this is equal to, where c, I will write here, where c is mod z equal to 1. Now, if I simplify this, this 2 gets cancelled. Done. And what is this part? 1 by I outside, I will write 1 by I outside. It is a constant. It is a constant. 1 minus, this is a by z, z square plus 1. Z square plus 1. I am taking z LCM here only in this part. Z square plus 1 plus a square 1 by z dz. Now take z LCM completely. 1 by I integral over c, z by z minus a into z square plus 1 plus a square z 1 by z dz. Now z terms gets cancelled. That is equal to 1 by I. Now I will write the quadratic expression minus a z square. And what is the z quotient? 1 plus a square into z. Here z1, here a square, and minus a will be there, dz. Dz. Any corrections? Right? Now, that is equal to, let us take, I will take, always remember, this is very important point, all of you. Remember, in this quadratic expression, take z square quotient as always 1. Make z square quotient as always 1. That is one important point. So minus a is common. Integral over c. 1 by, what is this? Z square minus a square plus 1 by a into z. Minus a is common, so this is plus 1. Take this as 1. And I'm taking this value as I. I stands for this integral. I stands for this integral. Okay. Got it? Now, let us consider. Now consider the integral. Now, consider the integral. What is that? Integral over c, 1 by z square a square plus 1 by a. If any corrections are there, suggest me immediately. Dz. Here, what is f of z? Here, what is f of z? 1 by z square a square plus 1 by a into z plus 1. This is f of z, right? The singularities are, I have to apply residue theorem, so I am applying yesterday's method. The singularities are z square a square plus 1 by a, z plus 1 equal to 0, denominator equal to 0. Done? So what are the roots becomes? Z equal to minus b, a square plus 1 by a minus b plus or minus root over a square plus 1 by a whole square minus 4ac by 2a. That implies z equal to a square plus 1 by a square plus 1 by a plus or minus a square plus 1 whole square minus 4 a square. Done? 4a square. This a square is outside common, so this is 1 by a will be there by 2. By 2. This is whole square is there. So here a square comes here. Now a square plus 1 by a plus or minus 1 by a. What is this formula? A plus b whole square minus 4ab. A plus b whole square minus 4ab. Formula is what? A minus b whole square. So what is this becomes? Root over a square minus 1 whole square by 2. So this is a square plus 1 by a plus or minus a square minus 1 by a whole by 2. So what are the roots now? A square plus 1 by a plus a square minus 1 by a. 1 by 2 is one root, and one other one, a square plus 1 by a minus a square minus 1 by a is another root. So this implies 1 by 2 in plus 1 1 gets cancelled. 2a square by a, 2a square by a, that is 2a. Another one, 1 by 2, a square gets cancelled. 1 minus 1, 2 by a. Is it correct? Right? So z equal to, the roots are a and 1 by a and 1 by a and 1 by a are the, what are the singularities and not repeated now? Therefore these are what? Simple poles. These are simple poles. And clearly in the problem, all of you remember, I have given one condition. What is that? 0 less than a less than 1. Okay, that is important. Okay, since 0 less than a less than 1, since 0 less than a less than 1, okay, which pole lies inside, say 0 less than a less than 1? 1 by a is greater than 1. 1 by a is greater than 1. Therefore z equal to a is less than 1. A is the simple pole, lies inside C. What is C? Mod z equal to 1. Since a value is less than 1, z equal to a lies inside C. That's it. There is no other, right? There is no other. 1 by a greater than 1, it lies outside. Therefore, what is the residue now? Residue of f of z at a. Since it is simple pole, what is the simple pole formula? Limit z tends to a, z minus a into f of z. So what is this? Limit z tends to a, z minus a into, what is f of z? What is f of z? 1 by, not 1 by, what is f of z? Yeah, 1 by z square minus this total, z square minus 1 by z square minus a square plus 1 by a into z plus 1. So I can write this, I can factorize this because I know the roots. What are the roots? One is a, another one is what? 1 by a, right? Now this 2 gets cancelled, and when I substitute a value, this is a minus 1 by a. So this is what? A by a square minus 1, residue. Residue of f of z at a is s1. Therefore, by using residue theorem, residue theorem, we have integral over c f of z dz. What is this value? 2 pi I into sum of residues at poles lies inside C. So what is this value? What is this? 1 by z square minus a square plus 1 by a into z plus 1 dz value. Dz value is 2 pi I into, what is, only one residue is here. So let us write that. So this value is 2 pi ai by a square minus 1. This value is over. Now substitute this value in equation 1. Substitute this value in equation 1. Okay, so what is 1 is nothing but I equal to, now let us see one equation. Yeah, minus 1 by ai by this integral. So I will write that minus 1 by ai integral over c 1 by z square minus a square plus 1 by a into z plus 1 dz. Done. So minus 1 by ai, what is this value? 2 pi ai by a square minus 1. So ai gets cancelled. So what is this value? 2 pi by 1 minus a square. Is that the required? 2 pi by 1 minus a square, right? I'm getting 2. So there's a mistake. 2 will be there. Yeah, 2 pi is there, 2 is there. Done. Exactly. So in the question, you change this. This is 2 pi I. 2 pi by 1 minus a square. Okay, once again I'm explaining this. To convert the real integral to complex integral, put e power I theta equal to z. Put e power I theta equal to z. Okay, then cosine theta value is z plus 1 by z by 2, and sine theta value is z minus 1 by z by 2i. Minus 1 by z by 2i. Okay, and substitute everything, and the curve becomes what? Mod z equal to 1. Curve becomes what? Mod z equal to 1. Then you can solve in that manner and substitute everything, and it goes to function of z, integral over c function of z. Okay, then I'm using residue theorem. For that I'm calculating poles which lies inside C and applying residue theorem and substituting the original equation. I'm getting the result, right? Next one. You take next problem. This is simple. Yeah, this is also simple. I need to tell one cosine problem. Let me check. Yeah, cos 2 theta by in the, okay, let me tell you this. Evaluate integral 0 to 2 pi cosine 3 theta by 5 minus 4 cos theta d theta. 5 minus 4 cos theta d theta. Okay, to evaluate this, see, in the textbook it is given in another way, but I will tell one short technique. Okay, it's a simple. Yeah, time is there, 20 minutes. That's enough for me. Now, put e power I theta equal to z. This implies, what is, shall I write directly? D theta is nothing but 1 by iz dz. This is standard one, no doubt. And what is cosine theta becomes then z plus 1 by z by 2. Z plus 1 by z by 2. And remember, here cosine 3 theta is there. Cosine 3 theta is there. In the textbook, cosine 3 theta is nothing but what? E power 3i theta plus e power minus 3i theta by 2. Then what you will get? Z cube plus 1 by z cube by 2. Problem will be very complicated, but I am not doing in that way. See, what I am doing here, integral 0 to 2 pi cosine 3 theta by 5 minus 4 cosine theta d theta is equal to integral 0 to 2 pi. I will write real part of e power I 3 theta. Real part of e power I 3 theta, correct? E power I 3 theta means what? Cos 3 theta plus I sin 3 theta. In that, I am selecting only cos 3 theta. That means the real part. 5 minus 4 cosine theta d theta. Now, this entire problem is nothing but what? Real part of integral 0 to 2 pi e power I 3 theta by 5 minus 4 cosine theta d theta. Okay, so that is equal to real part of what? Integral over c. I'm substituting now. Integral over c. E power I theta is z. E power I 3 theta is nothing but z cube. E power I 3 theta is nothing but z cube. So simply write z cube 5 minus 4 z plus 1 by z by 2 d theta is nothing but dz by iz, where c is what? Mod z equal to 1. C is mod z equal to 1, unit circle. Okay, if I substitute this, okay, then mod z is nothing but 1. Okay, these are the substitutions. Now the problem is what? I'm taking this problem as I. this problem as I. This is I. Done. So this I is nothing but now what? A real part of integral over C. 2 gets cancelled. So Z cube and ZZ get cancelled. Okay, let me write finally. This is 5 minus 2 into Z square plus 1 by Z dz by iz. Dz by iz. If any correction, suggest me. Right. This is equal to real part of integral over C. Again, Z LCM. Z power 4 out. This is 5Z minus 2Z square minus 2 dz by iz. Right. This is real part of integral over C. Z cube 1 by I outside. I will take C, all of you. This is very important. Okay, 1 by I. Real part is completely outside. 1 by I and minus 2 also take common. Minus 1 by 2I. Okay, always make Z square quotient as 1. Z square minus 2 is common means minus 5 by 2 Z plus 1. Plus 1 dz. Any corrections? Done? Okay. So I equal to real part of minus 1 by 2I integral over Ci Z cube by Z square minus 5Z by 2 plus 1 dz. Okay. This is equation 1. Now consider integral over C. This integral, complex integral, I have to consider 5Z by 2 plus 1 dz. Here what is f of z? Z cube by Z square minus 5Z by 2 plus 1. What are the singularities? Singularities are the denominator is equal to 0, right? So what is this? Is nothing but z equal to minus b plus or minus 25 by 4 minus 1 by 2 by 2. Now this equal to z equal to 5 by 2 plus or minus 25 minus 4, 16 by 4. No. 25 minus 4. Any corrections? Why I'm getting this? 21 I will get. No. 5 by 2 minus b plus or minus 25 by 4 minus this is 4. Yeah. Minus 4 AC by 2. Done. 16 means 9 by 4 by 2. This is 5 by 2 plus or minus 3 by 2 by 2. So z value is what? If I take plus 8 by 2 4 by 2 2. If I take minus 2 by 2 1 by 2 1 by 2 are the simple poles, not repeated, are the simple poles, and which lies inside, and clearly z equal to 1 by 2 lies inside mod z equal to 1, because 1 by 2 is less than 1. Since 1 by 2 less than 1 and 2 greater than 1, so outside. So find the residue at this point. F of z at 1 by 2. Simple pole formula. Limit z tends to 1 by 2. Z minus 1 by 2 into f of z. Done. What is f of z? Z cube. Okay. Done. This is equal to limit z tends to 1 by 2. Z minus 1 by 2. Z cube by z square minus 5z by 2 plus 1. And what is this? I can factorize this because I know the roots. For that purpose only, I am taking z square quotient as 1 to write like this: z minus 1 by 2, z minus 2. Now these two gets cancelled. 1 by 2 means 1 by 8, and this is 1 by 2 minus 2. Done. So this is 1 by 8, 1 minus 4 by 2. So 1 by, this is 2 4s are 12, minus 1 by 12. Is it correct? Any corrections? 4 minus 3. This is 1 by 2, 1 by 8. 1 by 2 minus 2, minus 3 by 2. Done. Correct. This is residue. Residue of f of z at 1 by 2. So apply residue theorem. By using residue theorem, integral over c, f of z dz is nothing but 2 pi I into sum of residues at poles lies inside C. So what is this value? This is integral over C, z cube by z square minus pi z by 2 plus 1 dz is nothing but 2 pi I into, what is this value? Minus 1 by 12. So minus pi I by 6. Substitute this value in 1. Substitute this value in equation 1. So 1 implies, what is that 1? I equal to real part of minus 1 by 2i. Okay. I equal to real part of minus 1 by 2i integral over c z cube by z square minus pi z by 2 plus 1 dz. Done. This is real part of minus 1 by 2i and this is minus pi I by 6. That is equal to real part of I gets cancelled, minus minus, this is pi by 12. In pi by 12 any I term is there? No. Therefore it's a real value. It is real. If any complex is there, I can separate that complex. Okay, this is I value. So what is this? I is nothing but what is integral? 0 to 2 pi cosine 3 theta by 5 minus 4 cosine theta d theta. Its value is pi by 12. This very simple. In textbook the problem is given very typical. He consider cos 3 theta as it is, but I am taking real part. Okay, this is the evaluation of real integral of the type f of cos theta sin theta integral 0 to 2 pi. Show that. Now try these problems. 0 to 2 pi, 1 by 1 minus 2a sin theta plus a square d theta equal to 2 pi by 1 minus a square, 0 less than a less than 1. Second one. Now our problem, cosine 2 theta, 0 to 2 pi, you apply real part of e power I theta. Okay, 1 minus 2a cosine theta plus a square d theta equal to 2 pi a square by 1 minus a square, 0 less than a less than 1. Next one, integral 0 to 2 pi 1 by a plus cosine theta d theta equal to 2 pi by root over a square minus 1, a greater than 1. And next one, integral 0 to 2 pi sine square theta by a plus b cos theta d theta equal to 2 pi by b square of a minus root of a square minus b square, 0 less than b less than a. 2 pi by b square, a minus a square minus b square. Right, another one. Integral 0 to 2 pi a by a square plus sine square theta d theta equal to 2 pi by root of 1 plus a square. A is greater than 0. A is greater than 0. And the last one, integral 0 to 2 pi 1 by 5 minus 3 cosine theta whole square. All of you solve this last problem. 5 pi by 32. 5 pi by 32. That's it. Any doubts in this case? 0 to 2 pi case, this one. Any doubts? If you want any clarification, I will explain again. Any doubts?